Okay, let's see if this one worked out for you. So again, we have the parentheses, so we have to start there. So we'll start with this first set. There's nothing to do inside of them. So we're going to multiply by the 2.4. 2.4 times 1.5x is 3.6x. 2.4 times 3.5, or negative 3.5, is a negative 8.4. Then this next set of parentheses, nothing to do in them again, so we're going to multiply by a negative 1.8. Negative 1.8 times 2.5x is negative 4.5x, correct? Negative 1.8 times a negative 1.5 is a positive 2.7. And now we're going to finish off this left side. Is there anything we can combine over here? Yeah, 3.6 and negative 4.5 make negative 0.5x. 8.4, 0.5, negative 0.9, isn't it? I don't know where the 0.5 came from. Negative 0.9x, is that correct? Okay. Negative 8.4 and a positive 2.7 make negative 5.7. And that equals, on the other side, there's nothing to do, so that's 1.6x and minus 9.8. Now what? First one, I'm going to stop there. Any questions so far? Okay, now what do we have to do? Okay, so there's x's on each side. I have to get rid of one. Negative is always smaller than a positive, so I'm going to get rid of the negative 0.9 by adding 0.9x, and it is gone. So all that's left over here is the negative 5.7. I have to add 0.9x on this side, which gives me 2.5x, yep, and negative 9.8. Then what? We're going to add 9.8. So we have just 2.5x on the right side. On the left side, negative 5.7 plus 9.8 is 4.1. Is that correct? I believe so. Yes? Yep, negative 5.7 plus 9.8. So negative 5.7 plus 9.8. Yep. So now what do we have to do? Perfect. We're going to divide by 2.5. 4.1 divided by 2.5 is 1.64. Equals x. How many of you had 1.64? Couple? That one was kind of tough. I'll give you that. Okay, so now next we are going to move on to an application of decimals and fractions, and one of the more important topics in math as far as I'm concerned, and that is the concept of percents. To understand percents, you must first understand the word percent. And it's actually two words. Per, you think of miles per hour or miles per gallon, it means for each or out of, and cent. If you think of years in a century or cents in a dollar, that stands for 100. So the term percent literally means out of 100. So if I list 38%, that literally means 38 out of 100. Now we've talked a little bit about ratios already. 38 out of 100, what's a short way of expressing that? 38 over 100, yes. In fact, it is that simple. That is how you change a percent into a fraction. It is simply out of 100, so you put it over 100. Now, we would not leave it as just 38 over 100 because looking at that, we see that we can do what to simplify it? Yeah, both the 38 and 100 can be divided by 2 to give me 19 out of 50. So 38% is the same as saying 19 out of every 50. Okay, so what if I have something like 65%? How do I express that as a fraction? 65 over 100. Am I done? No, what can be done with that? Divide by 5. 65 divided by 5 is 13. 100 divided by 5 is 20. So 13/20. So in your notes, what if I give you 40%? Turn that into a fraction. So 40% is 40 out of 100. Both of those can be reduced by 20. Very good. You get 2/5, 2 out of 5. Now it doesn't stay that easy. What if we have 37.5%? Well, we don't like having decimals within our fractions, but we do have to make this 37.5 out of 100. Now, a lot of us would shy away from that because we don't like to see that decimal in our fraction, but it is there. It's 37.5%. It's 37.5 out of 100. Now, when we were looking at dividing decimals, how did we get that decimal out of the fraction? What did we do? Yeah, times by 10 or 100 or 1,000 or whatever. What's it going to be here? 10. How do we know we had to multiply by 10? Only one decimal place. If there were 2 decimal places, we'd multiply by 100. 3 decimal places, we'd multiply by 1,000. The 37.5 times 10 is 375. 100 times 10 is 1,000. And now, of course, we're going to reduce this. Both of those can be divided by 25. 375 divided by 25 is 15. 1,000 divided by 25 is 40. Are we done? No, both of those can still be divided by 5. Get 3/8. So 37.5% is 3 out of 8. In your notes, try to convert for me 18.75% into a fraction. So this starts out as 18.75 over 100, just like any other percent. Then what do we do with it? Multiply by 100 because there's 2 decimal places. So this becomes 1,875 over 10,000. And then divide by what? Divided by 5. Let's start with 5. So if we divide by 5, that gives us what? 375 over 2,000. Okay, and then what? Let's divide by 5 again, which will give us 75 over 400. And then divide by, I'm going to jump up to 25 here. Gives us 3/16. How many of you got 3/16? Did you have 15/80ths? Well, we can also run into something like this. 18 1/3%. Well, 18 1/3% still means 18 1/3 out of 100. But just like we don't like having decimals within our fractions, we don't like having fractions within our fractions. We need to get rid of the fraction. There are 2 ways we could approach this. One way would be to just divide. Do 18 1/3 divided by 100. So I would make this 100 over 1. 18 1/3, well, 18 times 3 is 54, plus 1 is 55. That's 55 thirds. Instead of dividing by 100 over 1, we're going to multiply by 1 over 100. We can reduce by cross-canceling. 55 and 100 both divide by 5 to give me 11 and 20. 11 times 1 is 11. 3 times 20 is 60. So 18 1/3% is the same as saying 11 out of 60. The other way we could go about this is we could just multiply by the denominator. The denominator in this fraction is 3. So if I multiply, well, you got her? Right. The denominator, and I'm not talking about the denominator of the whole fraction, which would be the 100. I'm talking about the denominator of the fraction within the fraction is 3. 18 1/3 times 3 is 55. 100 times 3 is 300. And of course, we could reduce by 5 to get 11/60. Depending on how you are with fractions, one of those methods may be easier for you than the other. I like this one here where I can just divide it out, because those of you with fraction calculators, you can just type it in. 18 1/3 divided by 100, and it'll give you a fraction for it. So what if I have 36 2/3%? In your notes, try to convert that into a fraction for me without a percent. So this will become 36 2/3 over 100. What did you do with it from there? You multiplied by 3? Okay. So of course 100 times 3 is 300. 36 2/3 times 3 is 110. So that reduces, both of those can be divided by 10 to 11/30ths. Good. How many of you got 11/30ths? Good. How do we change things if we have 528%? Well, the answer is not a whole lot. It's still 528 over 100. A lot of people get uncomfortable here. How can the numerator be bigger than the denominator? Well, what is a whole thing? What percent represents the whole thing? Or represents one item? That would be 100%. 100% includes everything, right? It always bugged me when coaches say, all I ask is that you give me 110%. It's not possible. You can only give everything you have, which is 100%. 528% is more than 100%. So it is going to be more than 1. So when I look at this, the first thing I would probably do is, well, 100 goes into 528 5 times with 28 left over. At that point, it's pretty simple to see how many hundreds there are, so I can make it into a mixed number right there pretty quickly. And now I still have the 28 over 100, both of which can be divided by 4. 28 divided by 4 is 7. 100 divided by 4 is 25. So 5 and 7 25ths. Anybody come up with that? Good deal. So I want you to try this one on your own. 210%. Turn that into a fraction or a mixed number. So 210% is 210 over 100. Taking out the 100 twice with 10 left over, so 2 and 10 100ths. Dividing by 10 is 2 and 1/10. Not so bad? Okay, so we can convert our percents into fractions. A little bit simpler is converting our percents into decimals. Now we said earlier 38% becomes 38 out of 100. Now we reduced that fraction earlier, but if I'm going into a decimal, I'm going to leave it like that. How do I change a fraction into a decimal? Well, I just divide it out. That's 38 divided by 100. And at this point in the summer, we've done enough dividing that we know anything divided by 100, what happens to that number? Well, it just takes the decimal point and moves it over 2 spots, doesn't it? 38 divided by 100 becomes 0.38. So if I had 63%, that's going to become 63 over 100. Or 63 divided by 100, which is 0.63. So changing that percent into a decimal, all we were doing is dividing by 100, or moving that decimal point 2 spots. So if I had 19%, what is that as a decimal? 0.19. 87%, what's that as a decimal? 0.87, good. 8%, what is that as a decimal? 0.08, good. 250%, what is that as a decimal? 2.5, good. 6.38%. What is that going to be as a decimal? 0.0638. Yeah. Have to go 2 decimal places. Move divided by 100 still. %. What's that as a decimal? Five. Just 5. Only 2 spots, right? 5.9% is what is a decimal? Careful. 0.059. Good. Now here's the one that I'm going to get people on. I get almost everybody on this one. 1/4%. What's that as a decimal? Everybody's reflex is to say 0.25. Think about it. 1% is what is a decimal? 0.01. 1/4 is smaller than that, right? So 1/4 has to be smaller than 0.0.
0.025?
Close. 1/4% is 0.25%. Now I divide by 100. I still have to move 2 more spots. That's 0.0025. So you had the right idea. Again, if you look at that, if you made it 0.025, that's still bigger than 1%, so that can't be correct. This is what I call benchmarks. And when I work with percents, I use a lot of benchmarks. In fact, when I do any of my calculations that I do, I use benchmarks. I know just by looking at it, it has to be bigger or smaller than certain things, so that I know, okay, I keep that in my mind of, okay, if I get an answer that's different from what I expect, I'm going to double check this. That doesn't mean I keep my benchmarks correctly, but I keep benchmarks in my head. And this is an example that we know 1% is 0.01. 1/4 being smaller than 1 has to be smaller than 0.01 as a decimal. So if I get 0.025 or even 0.25, which is the common one that's given, I know those can't be true because they're bigger than 0.01. Now another strategy for checking your answers is always to reverse it. Since we know that going from a percent to a decimal, we divide by 100 or move the decimal point 2 spots to the left. Going the other way from a decimal to a percent, we're going to multiply by 100 or go 2 spots to the right. So if I have 0.65 and I want to change that into a percent. Now the justification here is 0.65 is not a fraction. Well, it is a shortcut for a fraction. But if I make it, if we looked at when we were doing our converting earlier to the nearest 8th or 16th or whatever, we made it a fraction by simply putting it over 1. So it's 0.65 over 1. Well, as a percent, what denominator does it have? 100. So to convert that percent, I have to multiply by 100 on top and bottom. So that's why when I go from a decimal to a percent, I am multiplying by 100, which means I'm just moving my decimal point 2 spots to the right. So 0.65 becomes 65%. Good. So what if I have 0.31? What's that going to become as a percent? 31%. Good. 0.07. What's that going to become as a percent? 7%. 0.086. What's that going to become as a percent? 8.6%. Good. 2.3. What's that going to become as a percent? 230%. Good. .0094, what's that going to become as a percent? .94%. Good. So going from a decimal to percent to a decimal, either way, is pretty simple. It's just a matter of moving the decimal point and making sure you are going 2 places no matter what. And only 2 places. Sometimes it's tempting to go less, sometimes it's tempting to go more. Going from a fraction back into a percent can be a little trickier. So I'm going to start with an example that pretty much all of you will know. The fraction 3/4, what's that going to become as a percent? 75%. Now, if we didn't just know that that was 75%, there are several ways we can get there. One way is just to convert 3/4 into a decimal by doing 3 divided by 4, which is 0.75. And then moving my decimal point 2 spots to make it 75%. That works, but it goes through a couple of different processes. You have to divide it out to make a decimal, then move the decimal point. Another way you could do this is to look at our proportions that we did a little bit before. 3/4 is 3 out of 4, and a percent is always out of 100. To find that missing number, we could think of it as fractions and figure out what do we have to multiply 4 by and then do the same to 3. But when we did proportions a week or so ago, we found a shortcut, which was to what? Cross multiply, then divide. So this would be 3 times 100 is 300, then divide by 4 is 75. So 3/4 is 75 out of 100, which is 75%. So if I have 5/8, converting that to a percent, same type of thing. 5 times 100 is 500. We'll divide by 8, which is going to be 62.5. So 5 out of 8 is the same as 62.5 out of 100, or 62.5%. Try to convert 3/7. So 3/7 into a percent. To the nearest 100th percent. Try that in your notes book. So we set it up as 3/7 equals blank over 100. To find that missing number, we're going to cross multiply. 3 times 100 is 300. And then we'll divide by the 7, which is 42.857143 approximately, right? So now to the nearest 100th percent, that's going to be what? 42.86. Because we look at that, 5 is in the 100th place, but the next digit is 7, so it rounds up to a 6. Okay, so we can convert fractions to decimals, decimals to fractions, and then now we can do fractions and decimals into percents and back. I should throw in something like this. How would we convert that into a percent? Well, if we're going to put it into a proportion, this has to be a fraction. So the first thing I would do is I would convert 5 1/5 into 5 times 5 is 25 plus 1 is 26/5. And now I can turn it into a percent by putting it over 100. 26 times 100 is 2600. divided by 5 is 520. So 520 over 100 is 520%. So to finish off the day here, we'll come back tomorrow and do more percents and calculating with percents and all sorts of that good stuff. And some big applications of percents. I tend to preach a little bit when it comes to some of the applications of percents. But anyway, to end today, I want to take a look at some more of these benchmarks. And I want to start out with 10%. Now, 10% means 10 out of 100. More importantly, that reduces to 1/10. Well, how do we find 1/10 of something? The simple way, the quick way of doing it is to do what? There you go. Move the decimal point over one spot. 1/10 means you're just going to divide by 10 or move the decimal one place. So if I asked you to find 10% of 280, what's it going to be? 28. If I asked you to find 10% of 513, what's it going to be? 51.3. If I asked you to find 10% of 6,200, what's it going to be? $620. 10% of 4.8 is going to be 0.48 or 0.48. We just have to move that decimal point over one spot. So let's talk about 1%. 1%, of course, is 1 out of 100. To find 1%, 1/100th, we just divide by 100, or move the decimal over two spots. So if I ask you to find 1% of 280, that would be 2.8. Good. 1% of 4,700 would be 47, right? 1% of 32 would be 0.32. Good. 1% of 6.8 would be 0.068. Good. So finding 1% of something is just moving the decimal point two spots, or dividing by 100. With that in mind, let's look at finding 12% of 4,100. Now, I know that many of you probably know how to calculate this directly, but I'm going to show you a little thing that I've used in the past, and I think is very significant. 12% can be broken down into 10%, 1%, and 1%. What is 10% of 4,100? $410. 10%. 1% would be 41. And 41, of course. If I add that up, I get 492. 12% of 4,100 is 492. Similar to something like that, I could ask you to find 9% of 8,300. Now for this one, it's a little bit different. 9% is going to be expressed as 10% minus 1%. What's 10% of the 8,300? $830. What's 1%? $83. Right? If we subtract, that gives us 747. That is 9% of 8,300. So what I want you to do in your notes, find 21% of 2,400. So 21 is going to be 10%, 10%, and 1%. So 10% of 2,400 is 240. So another 240 for the other 10%. 1% is 24. So that adds up to 504. How many of you got 504? You get confused? Okay. So it's one of those where not knowing anything about calculating with percents of what we're going to do tomorrow, you can actually get an exact answer here just by knowing your benchmarks of 10% and 1%. As I add up to 21. So you get up to 21%, I got to have 2 10s and a 1. Because that also has to add up. Now there are other benchmarks out there. I use the 10% and the 1% here because they're really simple. When I'm actually calculating, I do use other benchmarks. Like 50%, of course, is a fraction would be 50 out of 100, or 1/2. Certain numbers are fairly easy to find 1/2 of. If I wanted to find 50% of 340, what's that going to be? Well, half of 340 is 170. Or 50% of 2,800. What's half of 2,800? Careful. 1,400. There you go. Or half of 700. 50% of 700 is 350. So I can combine that with what I've known to find 49% of 320. Well, I would do 50% of 320, which is 160, and subtract 1%, which is 3.2. 50 minus 1 is 49%. 160 minus 3.2 is 156.8, which is 49% of 320. %. Not near as tricky as most people think to find. 5% can be thought of in one of two ways. It can be thought of as 10% of 50%, or in other words, 1/10 of half. What do I mean by that? Find 5% of 320. Well, first I'm going to find 50%, which is 160. That's half of 320. Then I'm going to find 10% of that, which is 1/10 or 16. So 5% of 320 is 16. Or the other way I could think about it is that it is 50% of 10%. In other words, saying it is half of 1/10. So looking at 5% of 320. Again, well, I could look at 10%, which is 1/10, which is 32. And of that, I could look at 50%, or 1/2, which is 16. Notice I got 16 either way. So even when I'm using these benchmarks, there are several ways to break things down, depending on what patterns work for you. Let's say I want to find 5% of 840. It all depends on how you think. Half of 840 is 420, then 10% of that would be 42. Some of you, it might be easier to say, hey, 10% of 840 is 84. Half of that is 42. It's really a matter of what's easiest in your head. Either way, you're combining 10% and 50%. It's 1/10 of 50% or it's 1/2 of 10%, either way. Now I notice that the 5% is trickier to do. I openly admit that. Find 26% of 320 using benchmarks. So you can see how I broke it down here. 25 and 1 add up to 26, and I broke the 20 into 2 10s. 10% of 320 is 32. 5% is just half of 10%, so that would be 16. Then 1% of the 320 is 3.2. I can add that up. Oops, to get 83.2, sound right? I'm not going to push this. There are some problems in the homework that allow you to work through these benchmarks. It's a great tool. Like I said, benchmarks are a way to make some fairly complex looking calculations relatively easy, and it's a great way to double check. I very seldom will I do exact calculations with benchmarks anymore, unless I'm trying to do something in front of the class. This is how I do a lot of my calculations quickly. I know that 19 is 2 tens minus 1 1, and if I know that, I can make that calculation go fairly quickly in my head. In a lot of other cases as well. But if nothing else, the benchmarks are a great way of setting up an estimate in my head, so I know that when I punch it in the calculator, whether I'm way off or not. Like here, if nothing else, 26% is just bigger than 25%, which is 1/4. 1/4 of 320 is 80, so I know my answer has to be slightly larger than 80. With that, I know I've been kind of heavy on the homework lately and kind of long in the speaking in class. So I am going to give you guys the last 30 minutes here to get started on stuff. You do have a new quiz today that is due tonight at 11:59 p.m. You have a homework that should be due at noon today from last Thursday. I think the computer's got it messed up at 11, but keep working on it if you want to. And there will be a new homework due tomorrow at noon. So you guys have the computer labs if you want to work. I'm going to be hanging around here for a while yet. So if you want to get started on stuff and ask questions, you're welcome to. Otherwise, we'll see you tomorrow.